Hello, my name is Steve Bowler, and in this video we're going to be configuring OSPF Virtual links, and we're also going to be showing you an alternative to using virtual links. For instance, if you're given a task that allows you not to use virtual links. So in this case we're going to connect area 6 to area 0 through area 23, but we are not going to be using virtual links. We're going to be using another method, an alternative to virtual links, which is GRE tunnels, to establish the connection between area 6 and area 0. From area 0 to area 5, we're going to be using virtual links. We're going to hop over router 4, which is in area 14, to get to area 0. So one thing to point out, we're going to go ahead and change the area IDs. We'll put the area on top to area 145 because it has router 5, router 4, and also router 1 in it. And then we're going to change the area on the bottom of our lab to area 236. And this is because it has router 2, 3, and 6 in it. Again, in OSPF, every area that you connect into OSPF has to be connected to area 0. There are exceptions to this, and this is what we're going to explore in this lab. We're going to look at GRE tunnels as an alternative and virtual links. In this scenario, we have created loopback interfaces, loopback 0 interfaces in on every router in this diagram. So R1 is 1.1.1.1 with the /32. Router 6 is 6.6.6.6/32. So we're going to be using these loopback 0 interfaces in this lab, as you will find out. Some of them are going to be very important to establishing reachability. What I have done already for us is I have created the network topology. I just need to go into area 5 and area 6 and create those loopbacks. I haven't even started OSPF yet, so we are going to start from scratch from router 1 enabling OSPF. We do that with the router OSPF process 1 command under global configuration mode. What we're going to do is we're going to put the fast Ethernet 00. One last thing we're going to do is we're going to show you the layout of the subnets. The link between router 1 and 2 is subnet 12. They make up area 0, which is the backbone. Area 236 consists of router 3, router 2 being in network 23, and also router 6 and router 3 being in area 36. Again, area 236. Router 4 and 1 are connected, and they make up subnet 14. That's going to be in area 145. Router 4 to 5 make up network 45, which is part of area 145. And then area 5 over here on the side with the loopback, it has the 55.5.5.5/24, and area 6 has loopback 66, which is 66.6.6.6/24. So that is our general network diagram in this lab. Let's set up area 0 first. We're going to put the interface fast Ethernet 00 in area 0. We'll do that by specifying 12.0. Again, we're going to use the /24. Anything on the 12 network within that subnet mask range will be running our advertise and establish neighbor adjacencies with other adjacent routers in area 0. You can also do more specific network commands like a host mask. You could make this 192.168.12.1 but let's just keep it simple in this lab. We are not going to run into any problems doing it this way. So again, the 12 network is in area 0. We also have a fast Ethernet 01 on router 1, which is going to router 4. We're going to advertise that network, which is 192.168.14.0 with a /24 wildcard bit mask in area 145. And that should be it for the configuration on router 1 so far. So let's go to router 2 now, and if we do a show IP interface brief, we can get the IP addresses. We'll do router OSPF for process 1. We'll do 12.0 for our network with the /24 wildcard bit, and we will be putting that in area 0. This is our connection again to router 1. So now we have formed a OSPF neighbor adjacency with router 1. The next thing we're going to do let's go ahead and verify the neighbor relationship on router 2. If I do a show IP OSPF neighbor, our neighbor ID is 1.1.1.1, which is router 1's highest IP address. Something to point out, how OSPF processes gets the process ID of the router. If I do show IP OSPF 1, we have the routing process of 2.2.2.2 on the local router, router 2. What we need to do is hard code this router ID in OSPF. What we will see is that virtual links use the router ID to establish the virtual link connections. So what happens if we don't hard code this router ID and say we add another interface, another loopback interface with a higher IP address, OSPF may reconverge and use this higher IP address, the interface with the higher IP, and thus causing you to take down your virtual links. So if your router ID changes, then that's it. Then your virtual links are toast. So we're going to hard code our router IDs within OSPF. On router 2 we'll call it 2.2.2.2, and we will do a show IP interface brief. We can see that loopback interface on router 2. So again, very important that you need to know that within 4 virtual links. It's always best practice to hard code the router ID on your routers in OSPF. So we'll give router 1 the router ID of 1.1.1.1. Again, that is one of the main purposes of our loopback interfaces in this lab, to make them the router ID under our OSPF domain. So the next thing, we're going to go under router 2. And we're going to go under OSPF process 1 and advertise the 23 network with the /24 wildcard. Actually, before we do this, let's keep it simple. We're going to do the top configuration. We will do the virtual link first, and then we will take a look at the GRE tunnel, which we'll do on the bottom half of our network topology. So let's go to router 4 and do a show IP interface brief. We'll go and enable OSPF process 1. We'll give it the router ID real fast, and then we will do the 14 network. We will advertise into 145. So we should see the neighbor adjacency come up right away, and we see that. We're also going to advertise our 45 network into OSPF. Also, we're just going to do that again as a /24 inside also of area 145. So now we should go to router 1, and if I do a show IP OSPF neighbor, I have a neighbor ID of 4.4.4.4, which is router 4. If I do a show IP route OSPF, we can see that we have, if I do a show IP route and look at the codes for the routes, capital O is OSPF, you have an IA route, which is an inter-area route, and what we're seeing on router 1, since we already have our Fast Ethernet 01 interface in area 145, this is what's called an intra-area route. If you don't see an IA next to it, this is what's called an intra-area route, meaning it's a route learned within the area and not outside of the area. We can see if we do a show IP OSPF database, router 1 has two areas that it's connected to, area 0 and area 145. And the 145 network that we're learning is via OSPF is the 45 network from router 4. So if we go ahead and try to ping that from router 1, we do have connectivity. So next we're going to go into router 5. Let's do a no router OSPF 1 just to make sure that I did not have OSPF on there previously. Let's go under R5 and just do a show run just to make sure that we don't have any previous OSPF configuration on it. So now let's go under router OSPF process 1. If I do a show IP interface brief, I did not create the loopback 55 yet, so let's create that real fast. Again, we're going to give it the 55.5.5.5/24 IP. Now let's go back under OSPF process 1, and we're going to do the network statement 192.168.45.0 with the /24, and we're going to put that in area 145. So now router 5 has a neighbor adjacency with router 4. Again, we're going to hard code the router ID, which is going to be our loopback 0, which is 5.5.5.5.5. If I do a show IP OSPF neighbor, I do see the neighbor ID of router 4. So if I do a show IP route OSPF, now I see an OIA route, which is an inter-area route, which is not, meaning that it is not in the same area that router 5 is in. Router 5 is in area 145, and this 12 network is in the backbone area, which is area 0. Let's see if we can ping this network, and we can see that we can ping to area 0 at this point. So at this point we are good to go. The next thing I'm going to configure within OSPF is what's called a virtual link. We're going to create a virtual link. We're going to link area 5 to area 0 across area 145. Let's create this area real fast. We'll go under the router OSPF process 1. Let's do a show IP interface brief. Let's do a network statement for our 55 network, our IP range. So we'll do 55.5.5.0 with /24, and we'll put that in area 55. On router 5, if I do a show IP OSPF database, I have two areas on this router, which is area 55 and 145, which, as we all know, we cannot do this. We have to have the router connected to area 0 for proper OSPF implementation. If we look from router 1's perspective, if I do a show IP route on R1, we do not have the route to the 55 network inside of our routing table on R1. So what we're going to do to make this happen is we're going to create a virtual link. It's going to bridge area 0 with area 5 through R4, which is in area 145. Again, now this is where our loopbacks are very important and where our router IDs are going to come into place. Let's go under router OSPF process 1, and we're going to do the command area and what we're going to do next is we're going to put the area that we are traversing to get to area 5 from router 1's perspective. So we're going to put 145 in. So we'll do area 145 virtual link, and then the virtual link that we're going to put is going to be the loopback IP. We're going to peer with router 5 via the virtual link. So we are going to put in, we're putting in area 145 virtual link, and then the loopback of router 5, the router ID. So we need to establish this both, it's a bidirectional link. So if I do a show IP OSPF virtual link, you can see that the virtual link to router 5.5.5.5 is down. If I do a show IP route, again, we still do not see any routes yet coming in from area 5. I'm sorry, from router 5 in area 5. So let's go back to router 5 and get it configured for the virtual link. If I go under router OSPF process 1, we will do the command area 145. Remember, this is the area that we traverse. They both know, router 1 and 5 both know about area 145. So this is very important for the virtual link to come up. So again, it's the area you're traversing to reach your neighbor, in this case area 145. So area 145 virtual link, we're going to be using router 1's router ID, our loopback in this case, which is 1.1.1.1. So again, we are establishing the virtual link across the router ID of the router in which we want to establish the link across. In this case is router 1. And what we can see once we hit enter there, we can see now that we have a neighbor adjacency has changed. If we go to router 5 and do a show IP route, I'm sorry, not on router 5, let's go to router 1. So if I do a show IP OSPF virtual links, we can see now that we have the virtual link to router 1.1.1.1, which is the router ID of R1, which is in area 0. We have it as is up now. It shows it as a point-to-point connection The adjacency state is full. We have hellos going across, and we have a bunch of other information. You can set the hellos and dead timers just like if you want to be faster or slower depending on the speed of your network. On router 1, if we do a show IP OSPF Virtual link, we see the link to router 5.5.5.5, which is the router ID of router 5, and then we see the state is point to point, and we are seeing the link up. If I do a show IP route now, we can see this OIA route that router 1 is learning about via the virtual link to the loopback 55 of router 5. So before we did this, router 1 had no idea about this. We bridged the link between area 5 to area 0 across area 145 over our virtual link. And so now we can see router 1 sees the link to router 5 via the virtual link. If I do a show IP OSPF database, you can see that our ping was successful there. If we do a show IP OSPF database, we have our two areas, which are area 0 and area 145. So now we are seeing the summary LSA for the link ID of 55.5.5.5 in our OSPF database. Before, that was not there. So that is pretty much it. That's how you create a virtual link within OSPF. The command is very simple. It's just one command on the edge routers. Again, router 4 is just all of router 4's interfaces are in area 145, so it is just a transit router. All the information is going from router 1 to router 5 and router 5 to router 1. So it's our edge routers in which we create our OSPF virtual link. On router 1 we put the command area 145, and then we put in the virtual link, which is the IP address or the router ID of R5. And then on R5 we did the same thing. We went into the OSPF process 1 and we created area 1, or we put in area 145, which is, and then we did the virtual link and used the router ID of router 1, which is 1.1.1.1. So once we did that, we saw the OSPF neighbor adjacency come up. We used the show IP OSPF virtual links command to verify that our virtual link is indeed up. So the virtual link is good. The next thing we're going to do is we're going to go and show you an alternative to the virtual links through the lower half of our network topology. And this alternative is what's called a GRE tunnel. So on router 2, let's go ahead and do a show IP route. So now we're seeing a bunch of routes on R2. Router 2 is explicitly in area 0 at this point and area 236. So it's learning a bunch of inter-area routes. It's seeing a bunch of routes from 145, and it's seeing also the link to area 5, the network in area 5. So that is what these OIA routes are in router 2's routing table. So these routes have been propagated through area 0 from router 1 to router 2. If I do a show IP OSPF database, it sees router 1 as the advertising router, router 5 as the advertising router for those links. If I do a show run pipe to begin OSPF, we see that we only have one network statement in router 2 for area 0. We'll go under router OSPF process 1. We will do a show IP interface brief and put in the 23.0 with the slash. Again, this is going to be in area 236. So we'll go ahead and add that network in to area 236. So in this case, router 2 is going to be the backbone between the area 236 and area 6. So it's going to be the area border router. So in this case, router 3 is going to be a transit router. If I go into router OSPF 1 and do the command show IP interface brief, we're going to put both of its fast Ethernet links into area 236. We'll do that with the network statement. We'll put in the 23 network first. Network 23 is going to be in area 236. And then we will also do the statement, with the network statement for the 36 subnet, and we're going to put that in area 236 as well. So now if I do a show IP interface brief, let's try to ping 23.2, which is our connection to router 2. We have connectivity, but looks like if I do a show IP OSPF neighbor, our neighbor adjacency has not come up. So it's probably something simple that we missed on router 2. If I do a show IP route, we are directly connected to router 3 via fast Ethernet 01. It's going to take us a second to troubleshoot this connection while our neighbor adjacency is not coming up. Let's do a show run pipe to begin OSPF and take a look at our OSPF configuration on router 2. What we can see, OSPF process 1 is running for 23.0. Oh, okay. As we can see, the network statement is messed up for the 23 network. So we'll go back under OSPF. We can see that the network statement is including the .0, and that is the problem with the host mask. Is if you slip up and put in the wrong network statement with the wrong host mask, then you're not going to advertise any IP out, any interface. So we forgot to do, instead of 23.3 we put in, 23.2 we put in 23.0. So we went ahead and, instead of 23.3 we put in 23.0 with a wildcard bit of 0.0.0.255, and we can see our OSPF adjacency came up instantaneously. Let's go into router 6 now, and we will go under OSPF process 1. We'll put in the network statement of 192.168.36.0 with the /24 wildcard, and that's going to be in area 236. We forgot to add loopback 66, so we're going to advertise loopback 66, or we're going to give it an IP of 66.6.6.6 with the /24 subnet mask. Let's go under OSPF, and we're going to add that network as well, the 66 network, into area 6. what we can see from our diagram is that router 2 is going to have no idea how to get to that network. If I do a show IP route, we do not have the 66 network in our routing table because, again, the 66 network on R6 is in area 6. Router 2 is the area border router for area 0 and 236. It sees this area is a discontiguous network. It's not connected to area 0, so it's not going to ever populate into the OSPF database and the routing table. What we did above on area 145, we used a virtual link over area 145. What we're going to do in this case, for this network in area 6, we're going to use a GRE tunnel implementation over area 236. So basically we're going to extend area 0 to area 6. The first thing we're going to do is create the tunnel on R6. We'll go under global config and do an interface tunnel 0. Now we have to have an IP address for this tunnel, so we're going to give it the IP address of 26.26.26.6 with a /24 subnet mask. Then we're going to have to specify our tunnel source, which is going to be we can add an interface or an IP address. What we're going to do in this lab, we're going to use the tunnel source on R6, which is going to be fast Ethernet 00. And the tunnel destination is going to be the IP address, which is going to be through area 236 to reach area 0. This tunnel IP is going to be 192.168.23.2. So again, this is the far end, the edge IP address of the tunnel from router 6 perspective. So 192.168.23.2, and that should be it. So now if I do a show IP route, we have to have that network in our router on R6, which we do have. The 23 network is in router 6 is routing table. So if I try to ping the 192.168.23.2, I know how to get to that OSPF area through area 236. So I can ping the tunnel destination. It's very important that you have connectivity to the tunnel destination and in order for the tunnel to come up. We'll go now under the other side, which is R2. We'll put in the interface tunnel 0. The tunnel IPs in this case have to be in the same network, so we're going to give the IP address 226.26.26.2 with a /24 subnet mask. The other end of this tunnel is the .6, which is router 6's IP address on the tunnel interface. The tunnel source on R2 is going to be the interface pointing out towards router 6, which in this case is fast Ethernet 01. Just in case the IPs change for the tunnel source, we can hard code in, instead of the IP, we can put in the interface, which from R2's perspective is fast Ethernet 01. So that's the source of our tunnel, and our tunnel destination is going to be an IP address, and this is going to be the IP address of the far side or the incoming IP from area 236 to router 6, which is going to be 192.168.36.6. So what we can see is the tunnel has come up. If I do a show IP interface brief, we can see our tunnel, it is up. Tunnel 0, which we just created on both router 2 and router 6. My question to you is, will that route now be in, do you think it's going to be, will the loopback 66 network on router 6 now be in area 0, be propagated to area 0? Let's take a look and do a show IP route. We see that it's not in there right now. If I try to do a ping to the tunnel of the far end, which is the .6 from R2, so we can see that we have connectivity to the tunnel. So we have created a tunnel across area 236 from router 2 to router 6, and we can ping through. What we want to do now is in area 0 on router 2 is we want to extend area 0 out. We need to add the tunnel subnet into area 0, because although the tunnel is up, if we go to router 6 and do a show IP route, it is up, but we still do not have the link between router 2 and router 6. So what we need to do in this case, we need to add this network into the OSPF area 0, which is the 26th network. What we are seeing on router 6, if we do a show IP route, it looks like I have the full routing table of the OSPF network. I can ping 55.5.5. Yes, I can ping 55.5.5.5, but it is not actually, our OSPF network is not working correctly. So this ping is using the source interface to reach that. If I go to router 5 and do a show IP route, I am not seeing the 66 network in router 5. So if I try to ping the 66 network from router 5, you can see that we do not have reachability. So again, it all goes back to what we were talking about on R2. This ping is a false indication on R6. It's using the exit interface, which is in a different area than area 6. It's area 236. So we have created the GRE tunnel, but the last step to have full IP reachability throughout our OSPF domain is to go and extend area 0. We need to add the 26 network, which is network 26.26.26.0 with the /24 wildcard bit, into area 0. And so now that that is done, if I go to router 5, let's do on router 6, if I do a show IP route, you can see that it looks like we have the full routing table in router 6's, from router 6's point of view. If I do a show IP route now on router 5, we can see now we can see that we have learned the 26 network via OSPF. So what do you think if I'm able to ping? Do you think I'll be able to reach the 66 network now? And the answer is no. We still cannot ping the 66 network. So let's go to router 6. If I do a show run on R6, we will look at the OSPF configuration, and what we can see is that we added network 6.6.6.0 with the /24 subnet into area 6, and then we have the other link into the 236 area. So the problem that we are running into here is that even though we have added the network statement on R2 for the tunnel network, we still need to add in the network statement on R2 since we already put the network command in on R2 for R6 is for the tunnel. We need to since we're just extending area 0 to R6, the next thing that we need to do, if we do a show IP route on R6, we can ping the 55 network, which is all the way across the other end of the network, but an OSPF in this case is using the tunnel. So this ping is going the outgoing interface on R6, which is 192.168.36. The 36 network. So if we go to router 5 and do a show IP route, that network is actually reachable to router 5, the 36 network. So it's learning it via area 0 from area 236. So what happens if I try to do this? If I go to R6 and source this ping, so the target will be 55.5.5.5. The repeat count will put to 10. Extended commands, yes, we will now source this from the loopback 66, which is the interface which is in area 6. What we can see is that this ping is failing from R6 to R5. This is because router 5 has no idea how to get to the 66 network because it has not learned it via OSPF, because the tunnel in which we created is not yet done. What we need to do is continue with we need to have reachability across. We have to have full IP reachability. So in this case we do not have reachability. So we do not have reachability from area 6 loopback to area 5's loopback. The last step we need to do is on router 6. We'll go into router OSPF 1 and we will do the network statement for 26.26.26.0 to /24 and put it in area 0. So this is going to put router 6 into area 0. And as we can see, right immediately when we put in that network statement, we have our OSPF adjacency with router 2 via the, before we just had the neighbor adjacency with router 3, now we have the neighbor adjacency with router 2 over the tunnel. You can see that by IP address, which is the .2. So now if we do go to router 5 and do a show IP route, we see the 66 network, the inter-area route, the route from area 6 being propagated properly through the OSPF domain. So let's go ahead and try to do the ping again. We'll do it with the target IP of 55.5.5.5, which is the loopback 55 on router 5, which is in area 5. We're going to source this ping from our loopback 66 IP address, which is in area 6. So now you can see that we have full IP reachability. So we have reachability now from area 6 to area 5. The things to remember with the GRE tunnel, we ran a GRE tunnel through area 236. The tunnel that we had the IP range specific to the tunnel that we had to advertise into area 0. We advertised it in area 0 on router 2 and router 6. Router 6, when that came up, the neighbor adjacency came up. Router 6 and router 2 established a neighbor adjacency within router 0, and then router 2 was able to propagate the routes from area 6 to area 0, from area 0 to 145 to area 5. So now all of our routers are in area 0 and have full reachability. So we can go to router 5 and try to do the opposite ping. We'll ping the interface or the network that's in area 6 on router 6. We will source it from area 5. And you can see that our ping is now successful. And we have full IP reachability. We did the virtual link on the top from area 5 to area 0 through area 145. With the virtual links, we used the router IDs, which were the loopback 0 interfaces, to establish the adjacency. The virtual link has to be on both sides, pointing towards the other router. The area command is area 145 that we used, and then virtual link, and then the other side's router ID. So router 1, it was area 145, virtual link 5.5.5.5, and then router 5, it was area 145, virtual link, area 145, virtual link 1.1.1.1, which is router 1's router ID. On the bottom was we created a GRE tunnel from router 6 to router 2. We used the tunnel IP address of the network of 26.26.26.0/24. We added the tunnel source on R6, which was the FA00, and the destination was 23.2. And the tunnel IP address on R6 was the .6 in the 26 network, and R2, the tunnel source, was the Fast Ethernet 01, and the tunnel destination was the 36.6 IP address. We made sure that we had reachability to the destination of the tunnel by doing pings. And the tunnel IP address on R2 was the .2. And then the last thing that we had to do that was very important is that we extended area 0 to router 6. So we put router 2, we put the network statement of the tunnel network, which is the 26.26.26.0. We put that into that subnet into area 0, and then we went on to router 6 and we added the network statement of 26.26.26.0/24, and we also put that into area 0. And then we ended the lab with sourcing the pings from area 5 to area 6 and also area 6 to area 5. And that is when we made sure that we had full IP reachability throughout our OSPF domain. So you have to always be prepared for these tasks. You never know when you might have to face this in real life or on some exam. So again, we laid a good foundation of OSPF virtual links and GRE tunnels across OSPF. So thanks for watching the video, and I hope to see you in the next one.